The third experiment is characteristics of enhancement mode Mosfet. Okay, enhancement mode. The component required is Mosfet. So this is a Mosfet. Okay, and the terminals are, keep it like this. So this is a gate, drain, source. Gate, drain, source. Okay. Gate, drain, source. Then 1 kilo ohm resistor, voltmeter. So voltmeter, power supply having itself is a voltmeter, V1 and V2. The range is 0 to 30, already written, 0 to 30. Okay. Then ammeter is this one. So 0 to 250 milliamps ranging ammeter. So this is a negative terminal, this is a positive terminal, negative terminal and positive terminal. Then the regulated power supply. So we require two power supplies. In a single unit we have two power supply, variable power supplies. And that's all. And circuit diagram. So this is your circuit diagram. Okay, this is your circuit diagram. So the first battery, positive terminal is connected to gate, positive terminal is connected to gate, and negative terminal is connected to ground. The drain terminal is connected to negative terminal of the ammeter. The positive terminal of the ammeter is connected to 1 kilo ohm load. This is RL. The other end of the RL is connected to reference voltage or supply voltage to positive terminal, and the negative terminal of the supply voltage is connected to ground. So these two is not required. The voltmeter is not required because these two voltmeters which is having in a power unit itself. And this one MOSFET symbol is not like enhancement MOSFET is not like this. So enhancement MOSFET somewhat like this. So this is your enhancement. This is a drain, this is source, and this is gate. So this is gate. So make sure that you should replace this one over here. Okay. And the connections we have already made. I tell you how to do the connections. So power supply. So ammeter device, MOSFET device, 1 kilo ohm resistors, and connection we did like this. Just check it out. Okay. First gate terminal. So which is a gate terminal? This one. So this gate terminal is connected to power supply 1. This gate terminal is connected to power supply 1, positive terminal of the power supply, and negative terminal of the power supply is connected to common point. So here is, this is the common point, and as well the source terminal is connected to common points directly. The circuit, see, the source is directly connected to common point, ground. The positive terminal of the battery is connected to gate. Okay, the positive terminal is connected to gate. Now for the drain terminal. So this is the drain terminal. The black one is the drain terminal. From the drain terminal, the negative terminal of the ammeter is connected. From the drain terminal, the negative terminal of the ammeter is connected. Then positive terminal of the ammeter is connected to load, 1 kilo ohm load. The other end of the load terminal is connected to positive terminal of the other power supply, let us say V2, and the negative terminal of the power supply is connected to ground again. So this is your circuit setup. Now switch on your circuit and switch on your power supply, and make sure that initially both the power supply should be 0 position, and current always must be in high. And switch on your ammeter supply also. Okay. Now how to conduct the experiment? So first we need to do transconductance. Afterwards we need to do drain characteristics. So in a transconductance, VGS we are going to varying, keeping VDS constant. So VGS is initially 1 volt, 2 volt, then 3 volt. After that 3 volts, you should vary in steps of 0.1, 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9 up to 4 volts. Okay. Now keep constant VDS. So which is a VDS? VDS is this one and VGS is this supply. Keep 5 volts by using coarse terminal 5 volts VDS to 5 volts. Okay, and start varying in steps of 1, 2, 3 volts VGS voltage. So initially 1 for 1 volt. So 1 volt. So what is the current? What is the current from the ammeter? So 0. Put 0. ID current is 0 milliamps. ID always in milliamps. 0 milliamps. Keep 2. For 2, ID current is 0. For 3, is very sensitive, so make use of voltage fine also, voltage fine knob. So for okay, so approximately 1 you are getting, or 0 only, 0 for 3 also 0, for 3.1, for 3.1 you are getting 4 milliamps, you are getting 4 milliamps, for 3.2, 5 milliamps, for 3.3, 5 milliamps. So afterwards it will get constant. Even if you vary VGS, it will get constant. Okay. Now change the VDS voltage to 10 volts. VDS to 10 volts. Okay. Again start varying from the same pattern, repeat it. So again for 1, for 0, for 1, 0, for 2, approximate value, for 2, again 0, for 3, 0, for 3.1, for this is for 2.9, for 3 we will get 2, for 3.1, we will get 5, for 3.2 we will get 7, for 3.3 we will get 10, for 3.4 we will get 10. So afterwards it will remains constant. Afterwards it will remains constant even if you vary the voltage. It remains constant. Understood? Now look at the table. So for VDS is 5 volts. VDS is 5 volts. So VGS for 3.2 onwards it will get constant. VDS is 5 volts. So VGS 3.2 onwards ID current become constant. The same way for VDS 10 volts at 3.3 VGS ID current get constant. ID current get constant. So make a note. So now go for a drain characteristics. Keep VGS equal to 3.2 first one, and for the second VGS equal to 3.3. For a drain characteristics, VGS is equal to 3.2, because from 3.2 onwards it will get constant, and for the next reading for 3.3 it will get constant. So keep VGS 3.2 first, then 3.3 for the next constant for the drain characteristics, and vary the VDS in steps of 0.1. Vary the VDS in steps of 0.1, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9 up to 1 or 1.1, 1.2, 1.3. We take up to 1.3. Now keep VDS is constant. How much? 3.2, and vary your VDS in steps of 0.1. So make use of voltage fine. So 0.1 for 0.1, 0.200, the ID current 0.10, 0.20, then 0.3 also 0. Just check it out. For 0.3 also 0. For 0.4 0. For 0.5 0. 0.6 0. 0.7 0. 0.8 0. 0.9 0. For 1 you are getting 1. So up to 0.90, up to 0.9 you are getting 0. So for 1 VDS you are getting 1 milliamps. So for 1.1 again 1, 1.2, 1, 1.3 up to it will become constant afterwards. So 1, 1, 1. So 1, 1, 1. Now again change VGS to 3.3 by using level voltage fine. 3.3. Now decrease it again VDS. Again start the same fashion, same pattern. For 0.1 0, 0.20, 0.30, 0.4 0, 0.50, 0.6 0, 0.7 0, 0.8 0, 0.9 1. So up to 0.80, 0.80 up to 0.80 for 0.91, 0.91 for 1, for 1 also 1, for 0.1 1, 0.2 1, 0.3 1, 0.4 1, so 0.5 1, so it will become constant. For 0.8 you will get 2. So if you the transconductance characteristics, ID current versus VGS in volts. So you should draw like this: 1 volts, 2 volts, 3 volts. 1 unit is equal to 1 volts. Even for ID current, 1 unit is equal to 1 milliamps, 2 milliamps, 3 milliamps. 3 milliamps. For VDS equal to 5 volts, you will get this curve. For VDS is equal to 10 volts, you will get this curve. And for drain characteristics, ID versus VDS. ID versus VDS. For ID versus VDS. For VGS is equal to 3.2 volts, you will get this characteristics. For VGS is equal to 3.3 volts, you will get this. For 3.2, you will get 1 volts constant. For 3.3, you will get 3 volts constant. This is output characteristics.